Okay, this one's going to require us to use substitution, but then we also have to put our numbers in, so this one's going to have a numerical answer. First thing we want to do is look for the u. Now the u is always going to be whatever is something inside of something else or raised to a power is typically what the u is. So all this right here inside is going to be our u. So u equals 3x squared minus 10x plus 3. We're going to take the derivative of both sides with respect to x. So du is equal to 6x minus 10 when we apply the power rule on that. As always, you want to solve for dx. So dx is equal to du over 6x minus 10. Now, it might be good to factor this one on the bottom. And so that's what I'm going to do next is just factor this bottom part. So if I factor out a 2 there for each one of those, let me do that here. If I factor out a 2, 3x minus 5. So it's better to write it in a factored form, and that's because of this next thing up here. This one I'm going to factor as well, and then we can more easily see what we're going to cancel out from the top and bottom. So for situations like this, it's actually better to factor that before you plug that into the other one. So now we're ready to plug it back into here. We're going to go integral. I'm going to temporarily leave off the 0 and 3 because we'll put that in later once we integrate this and find the exact function that we're going to use. That's u cubed. Now this one, as I mentioned before, it's always good to factor this as well. So if you look at both of these, we can pull out an 8. 8 is your common factor, and you get 3x minus 5. We'll put the dx in, du over 2 times 3x minus 5. So as you can see there, that's the reason why you want to do factoring, is because then you can see what part is going to cancel out there. So we see here that 3x minus 5 and 3x minus 5 are both going to cancel out. Then you can do 8 divided by 2 is 4. That's going to go outside the integral. And then you have u cubed left over. Now always it seems like what happens on a test, which I know students doing, is they'll get down to here and then just put the u in at this step and then plug the numbers in. You didn't integrate yet. So you don't want to just go down to here and end. You want to do one more step and actually integrate it. So you want to use the inverse power rule on that. Raise the power by 1, divide by the new power. The 4s are going to cancel out, and you're going to get u to the 4th power when these cancel. And so it's basically going to be 3x squared minus 10x plus 3. That's going to be to the 4th power. So now what we're ready to do is we're ready now to plug in the numbers. So by going through all that, I'll put that up here. What we have left over now is we have 3x squared minus 10x plus 3, and that's all raised to the 4th power. And now we're doing this. We're going to put in our limits of integration in for each of those now that we've gone through and finished that. Okay, so you put the 3 in there first, then you put the 0 in. So I'm going to do that part here. So we have 3 times 3 squared minus 10 times 3 plus 3. All that is to the 4th power. And then now you're going to put in a 0 in there for those. Just like this, that's the 4th power as well. Now this part here, you're going to get 9 times 3, 27. 27 plus 3 is 30, and then minus 30 is 0. So we get a 0 for that one. And this next one, we're going to combine all that. These two things are a 0, and you get a 3 to the 4th. Now, it's important to point out here that, notice I put the 0 in for the second one. A lot of times, it's common to think that, oh, if I just put a 0 in, that means always the whole thing's going to be a 0. That's not always the case. For some functions it is, but this one it's not. So it's always good to plug the number in, whether or not you think it's going to go to 0. Plug it in anyway, because now, like I said, this one here, we end up getting a 3 inside. So what the answer is going to be negative 81 for the whole thing. That's our final answer by going through all that. So again, be careful here. Make sure you plug both the numbers in and work that out because we do get an actual answer. Otherwise, if you just put a 0 in here, then the whole thing would just cancel out and give you a 0. So it's important to know that your answer is negative 81.